Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about next-generation hyperscale database with Aerospike. Our special guest today is Tim Faulkes, VP of Solutions Architecture at Aerospike. Tim, welcome to the show.
Hey, Darren, thanks for having me on. I appreciate it.
Hey, we've had quite a few conversations now, and I've really enjoyed talking to you about your technology, especially because it uses Intel inside, right? I mean, of course, I'm excited about that, but really, I'm really excited with what you guys have done with our new technology and kind of put a new spin on something that's kind of old. Databases are old, right? I mean, they've been around for a long time, but you guys have done some incredible things with this.
Mm-hmm. They have been around for a long time, and they're showing their age, honestly. Everyone's used to the relational technologies and getting results, but taking some time to get the results. And Aerospike's designed to give you the results when you need them, here and now.
And that's one of the things I love about it, just the quickness of it, how fast it is, and also the sheer volume of data that you can push through your database is just amazing.
Mm-hmm. Yeah, and there's several things about Aerospike that make it unique. I mean, yes, volume is a big thing. And when we talk to our customers, they say, I have lots of data. And that means so many different things to so many different people. And in Aerospike, I've got customers that are in the several petabyte range. And they love the fact that they can get the access to the data, and typically they'll get any piece of data out of that and get it in sub-millisecond timeframes. And that's very unique to Aerospike.
All right, so tell me the story. Tell me the story of Aerospike. All of our listeners want to hear. What's the deal here? Well,
we were designed from the ground up to face the challenges that people are just beginning to realize now. So, we were created in 2009. Our first production deployments were in 2011. But at the time, our co-founders were very forward-thinking. They were looking at the challenges that are coming up. One of our co-founders worked at Yahoo, for example, and wanted to make sure that even in the busiest peak times of high news cycles, nothing went down. So they came with that frame of mind. And so we were designed from the ground up to be reliable, to be enterprise scale, to never go down, and to be able to handle massive ingests of data. Now, at that time, the technology that we used was in its infancy. So we rely very heavily on SSDs, be they NVMe drives in the modern incantation, or be they typical SATA SAS drives. And in those days, they were in the infancy, so I was very forward thinking of them, looking at where is the market going. And now we rely on those devices to get the speed. And obviously that's why we like Intel so much. You've got some wonderful drives out there, but all the other technologies that have come out of Intel have really made things a lot easier. For example, the persistent memory that came out, we make full use of that and use it to the best of its ability.
Well, and that's what I really like about your guys' architecture. You rethought databases, because database technology, I learned that in school, right? I learned how to write my own relational database, and you're dealing with, I remember we talked about spindle count and sectors on drives, right? Because that's what you have, but the media has changed. And what I love about your guys' technology is you said, we're going to think about databases differently, right? We don't have to do it the old way because the media has changed. We don't have to think of it the same way, and you architected a new way of doing things, which really is lending itself well to this new technology that we have.
Yeah, correct. And everyone looks at the technologies we're using, SSDs, as a faster hard drive, and it's not. It's a very, very different characteristics. A hard drive has physical sectors and heads and things it has to move to read data. An SSD can read thousands of pieces of data in parallel and do that really, really quickly. And so we're architected from the ground up to do that. We don't run well on rotational drives. We run terribly on rotational drives. But give us a nice NVMe SSD, and we run blazingly fast. And almost no one has the same sort of performance. Even in-memory databases struggle to keep up with our performance of getting the information off storage. That's how fast we are and how good the technology we use is.
Okay, so now I've got this ultra fast, no SQL database, right?
Mhm.
Huge ingestion. In fact, we were talking the other day. I no longer need an ingestion engine, right? That just ingests and then decides which database to put it to. I can put it directly into persistent store. I just removed one step of handling data. That's
Correct.
huge.
Yeah, it is huge. And customers are loving that about Aerospike. So our architecture is very unique. Yes, we use SSDs, but we're designed for high volume, high throughput, very low latency. And to give you just throwing out some numbers of my customers, I've got customers who are doing regularly 20 million transactions per second. That's reads, writes, combinations, therefore of. Customers going up to petabytes of data. And typically, I've got customers who run on fairly nice hardware, but their round trip time, client to server, go and look up a piece of data and bring it back to the client. That takes about 200 microseconds. We're not talking tens of milliseconds or hundreds of milliseconds to get some data. So if you're doing something like fraud detection, you need lots of data, you need it fast. If you're doing ingestion, you've got lots of data coming in from sources, and we're finding lots of demand in IoT, particularly for autonomous vehicles, sensor readings, medical fields, medical devices. You've got to be able to ingest that data, and you've got to be able to do it quickly. And Aerospike can do those millions of transactions per second across reads and writes, and so that ingest becomes easy. You don't need to put it into a message bus to have the slow database be able to consume it. Put it into the database, and then let the database notify downstream systems via the message bus that it's got the data. It's already persistent.
Yeah, it turns things upside down, which makes things faster. It's truly amazing. So let's talk a little bit about use cases.
Mhm.
You mentioned a couple, right? You mentioned fraud detection. You mentioned IoT. What other use cases do you see as a sweet spot for this technology?
So it's an emerging market. So we started in ad tech. So the ad techs are the people who show you the ads on your phone or your browsers when you log on. It was where we grew up, and it's a very interesting area because they have such tight technical requirements. From the time I load a web page to the time I have an ad shown on it, they have 100 milliseconds, and they have lots of online biddings. It's a full marketplace. So their data retrieval has to be done in milliseconds or faster. So growing up there allowed us to grow into this, hey, we've got very good performance, it's been battle tested, and high scale. What we're finding these days is everyone is getting more and more data. So fraud detection is a big area. Know your customer. The more intimacy you get with your customer, the better. There's a very large telco in India who uses Aerospike. And the infrastructure in India isn't necessarily as reliable as sometimes we have in the States. So you might be driving along and your call drops. This company can, in real time, detect that the call has dropped and say, oh, this customer's satisfaction rating with us has dropped. We should go and send them some credits or something like that to compensate them or give them some special offers. We're doing things like a new area that we're in and very heavily in now is real-time digital payments. This is a somewhat odd area for us. It doesn't have specifically a lot of data. It doesn't have a lot of high throughput. A couple of seconds is fine. But what they need is absolute consistency and absolute availability. So even in the face of losing a data center or anything like that, we want to be able to make sure that we've got as much information there, and it has to be consistent as is possible. So we mentioned IoT, being able to bring in a lot of information, ingestion from cars, data. The manufacturing floor seems to be a big area for us as well. Particularly in things like semiconductor manufacturing. If a part goes wrong and it breaks the supply chain, it causes massive downstream bottlenecks. So people are using it to store the sensor data and then do real-time analytics on the sensor data and say, this is my readings, does it look anomalous? Do I need to alert someone at this point? As well as downstream sensor data. There's also a strong presence in telcos, anywhere where there's lots and lots of data and you need it quickly. And you don't just need a small set of it quickly. Any reading across any number of records, you want that super fast. That's where Aerospike really shines.
I mean, you guys are replacing some other players that are out there, obviously, right?
Correct.
Right. So who would you guys say you go up against? I
So
mean, what are you going to replace with this?
yeah, okay. So there's a lot of NoSQL databases out there, and they're very good technologies. They all have a reason for being. But what most people find is challenges of scale. So if I look at Redis, for example, it's an in-memory database. It's very, very fast. It stores all its information in memory. Scaling becomes more of a challenge. Because it's storing all its information in memory, I can't go up to tens of terabytes without significant cost, let alone hundreds of terabytes or petabytes. So we have customers who come to us and they start on something like Redis and then they try and scale and they hit these bottlenecks. The performance difference between Aerospike and Redis, Aerospike can store all its information in memory, but then we get that expensive cost we're talking about. If we store our information on SSDs, the time difference between looking up data out of memory and out of an SSD is about 100 microseconds. So we get the same sort of performance as an in-memory database like Redis, but across the scales of petabytes that we've spoken about. We replace older technologies like Cassandra. Again, it's a very good technology. It has a great purpose in life and it scales really well, but it's not super fast. And because it's so prevalent, people try and scale with it and do things that make it very fast. So real-time digital identity management. People, we've got one customer who came to us, they loved Cassandra, they used it heavily, but they knew they were growing and they knew that as they doubled the data volume and they wanted to keep latency the same, they effectively would have to more than double the number of nodes. It was an exponential cost growth. With Aerospike, it's a linear cost growth. We took their data and we dropped it down. So I think they were going to be on about 250 nodes of Cassandra. They end up running on 28 nodes of Aerospike and saved a lot of money, got much better throughput and much lower latency.
So it's really interesting because you guys almost fit, you take the best of both of those solutions, Redis, right, very fast in memory, and Cassandra, slower, but can scale. You scale more linear, and you're just as fast as Redis.
Correct. Yeah.
Wow, that's incredible, right?
Yeah. And the other thing that I should mention is compared to those technologies, people save a lot of money moving to Aerospike. We drop the number of nodes down because of our unique architecture. I had one customer move from 450 nodes of open source Cassandra, and they ended up running on 60 nodes of Aerospike. Same use case, slightly different instance types. And yes, our nodes are a bit more expensive, but they saved a lot of money because, if you pay twice as much for the hardware, but you save 7 times the amount of hardware, it's a substantial savings.
Well, and it's not just CapEx costs that you're savings on. You're saving on OpEx costs, right? Because you need so many sysadmins per 1,000 machines. We all know, we've all been through that, right? Upgrading, all that stuff adds up, right? So this is a great story. Now, I also see you guys collapsing some of the tiers that have traditionally been separate.
Yes.
Right? Can you explain that a little bit?
Yeah, absolutely. So what we find more and more is that people are finding they have more data. They need it faster. There's more real-time needs. And it doesn't matter if you're using a NoSQL technology like we've spoken about or a relational database. Quite often you'll find that people have these more legacy systems, and to get the speed out, they put an extra cache in front of it. That cache is RAM heavy. It changes the application. In terms of the design of the application, you have to be more careful about writes and when you write it to the cache, when you write it to the system of record, and it introduces complexity. Aerospike does not need a cache. We don't have large amounts of DRAM requirements. We rely on the speed of the SSDs and our underlying technology to make sure that we can get that performance off raw storage without a cache. So we collapse that cache plus data set into a simple database. And we've got stories doing this in fraud detection in financial services with mainframe replacements and augmentation. There's many situations where the removal of that cache, the ability to get that performance, really adds business value.
So you're in some ways, you're collapsing the tiers that we normally see, those caching tiers and storage tiers. So it's now one. That simplifies the solution quite a bit, which means high reliability, speed, all that's kind of built in then.
Yeah, correct. And the other thing to think about is modern architectures these days require very low latency. And that typically means that you have a whole bunch of edge-based clusters where your data sits very close to the user. Otherwise, the speed of light becomes a factor. So Aerospike deploys geographically in a couple of interesting ways. First is we can have all those edge-based clusters talking to each other. So if I change my record in one cluster, it will automatically propagate to the other clusters. That's done asynchronously, so it's very quick. But we find more and more in things like digital payments, people need strong consistency between those edge-based clusters. So they might want to replicate that data synchronously. They might have clusters spread across the world, but they want to replicate the data synchronously between it. When they go and read the data, they'd rather read from the local copy of the data. So their reads become very fast. The writes get affected by the speed of light, but they guarantee consistency across geographical distances. So this isn't conflict resolution, this is conflict avoidance. And we're finding that people use this in particularly systems of records. Aerospike can run in strong consistency where we guarantee not to lose any records. And so being able to spread those strong consistency writes around the world and maybe have multiple systems of records has enormous potential and value to many of our customers.
So not only speed, but you also have that consistency because of where you guys grew up, right? You guys grew up in content delivery, right? Where consistency across multiple geographic areas is important.
Funnily enough, the ad tech area is not so concerned about consistency. They would much rather have availability. And,
that makes sense.
I've had a customer say to me, if I lose 10% of my data, I don't care, which I've had to pick myself up off the floor afterwards. But now we're in financial services and digital payments and account balances and things like that.
Yeah, everything matters.
Yeah.
No, very, very, very cool stuff. All right, so where is Aerospike headed? I mean, are you guys completely cooked? Everything's working great. I mean, where do you see the future? Where do you see Aerospike heading?
Look, Aerospike is a very strong, robust product at the moment, but there's a lot of things we'd like to do to it. So we believe we excel in these the situations where you need lots of data, and you need key value records, and you need to ultra fast. But there's things that we don't do. We're not a SQL database, so we're a NoSQL database. We don't do multi-record transactions at the moment. We don't do some other things that would be nice. So we're heading into these areas where our long-term roadmap is we want to expand the market. People have this need for speed, and we see it coming more and more. But they want to do other things. They want to be able to have a more slow mode where I want to be able to interrogate and do analytics or investigate my data with a SQL interface. The AI world is something that we're really, really interested in. So we currently interface with Spark very nicely. Spark, as you're aware, is a technology that does analytics really well, but it requires its data to be in memory to get those analytics to run really quickly. So you can't do analytics on tens of terabytes or hundreds of terabytes without enormous cost. So Aerospike and fuses with Spark, so you can go and load your appropriate data off Aerospike, put it into a Spark data frame and process it. So if I'm doing credit card processing, someone swipes their credit card, I want to go and load a lot of information. I want to load the customer, the account, the merchant, the terminal, and the transaction history associated with all of those entities. It might be hundreds of thousands of records, and I want to analyze it all at once. So I put them into a Spark data frame, and Spark analyzes it. So we're looking at integration with other AI tools, and we really see that play in AI as one of the big driving forces that will really help us in the future, and that opens some very, very exciting doors.
So this is really, I'm glad you brought up the ecosystem that you're talking about. You're going to focus on AI. That's great. That's like a consumer of the data. You guys also have a really rich front end to this. How do I get data into Aerospike, right? Mm-hmm. You already have a connection or connectors. I mean, explain how that works.
Sure. So if I'm writing an application, I have an API layer, like almost all databases. But if I want to be able to ingest from industry standard sources, I would typically use a message bus to be able to put them on.
Right.
So at the moment, we support ingest data from things like Kafka and JMS, and we keep up to date with the technology. So we're in the latest stage of creating a Flink adapter, Pulsar, and things like that. So we really believe that this bidirectional ability to talk to these buses makes a lot of sense, because not only with Aerospike can you ingest the data from these sources, but you can egress them. If Aerospike is a system of record, a source of truth, when you write a record, you want to be able to push it to downstream systems. You might have data warehouses downstream or other data systems that want to know about this and say, hey, I've received that data, I need to go and load that from Aerospike. So we have a lot of drive towards this ecosystem and the areas around it.
Now, let's say I don't want an ingestion engine on the front end of Aerospike, right? I want to use Aerospike as my ingestion. How easy is it for me to now maybe hook up data being streamed in from the CAN bus of automobiles?
Yeah.
I mean, is it difficult, or do I still need some kind of ingestion engine on the front end of Aerospike?
It really depends what you want to do with that data. So you mentioned CAN bus, which is a great example. So is the information that you streamed in the right format? Do you need to transform that data on the fly? Typically, what we find is there's an application that receives that telemetry data from the CAN bus sensors.
Right.
That application does, it might break that information up and put it into smaller discrete chunks, and typically it'll put on a message bus. It might keep it in the same format and put on a message bus. With Aerospike, it can do that. It can decide whether it wants to break it up or keep it in the same format, and then just put it into Aerospike. So just calls an API call, and it's as easy as putting it on a message bus, but instead now it goes into persistent storage.
And how can I scale? I mean, obviously I've got to have an Aerospike client of some sort, right? How many clients can a typical, I mean, what's my fan? Can I have 100,000 of these clients running against one Aerospike database, or 1,000? I mean, how do you guys scale? How does that work?
Yeah, we do scale very well. So 100,000 is probably extreme, but certainly we've got thousands of clients. And what we typically find is, if I'm running a program, so I'm ingesting from my CAN bus, I might have lots and lots of threads that are processing that information simultaneously. They would all use the same Aerospike client. So our client is designed to be multi-threaded and scale, so you typically have one per process, and ingest lots of data with that. Now, for the sake of speed, our client is smart. It knows about the state of the cluster. For any record in the known universe, it can do a single network hop from the client to the node that owns that piece of data. So we don't have coordinators or load balancers or middlemen of any description. We just go directly to that node. And so that means that we have to know, the client has to know about all the nodes. So we do have finite connection limits. So that's why hundreds of thousands probably isn't practical, but definitely thousands of clients becomes very possible.
Now, what if I do need 100,000?
If you
right?
do, well,
I mean, how would I set that up? Multiple Aerospike instances that are then sharing information back and forth. I set up clusters. How big can I really scale this?
Yeah, so that's a great question. And typically in this scenario, if you've got hundreds of thousands of clients, the reason you've got it is because you've got a globally distributed population. And
yes, more than likely, yeah.
If they're all talking to one cluster, speed of light becomes a big issue. The client's got to send that information over the wire. So we see smaller, discrete, edge-based clusters, and they either share information or they then go and talk to a system of record in more of a hub and spoke model. So there's definite ways of setting it up.
So I could aggregate the data, right? I don't have to send all the data to a central one. I can aggregate data, send aggregated data up.
Correct.
So I can use Aerospike as that. I love how you said it's the golden data, right? It's my data of record.
Yep.
Because I'm ingesting it, it's there, and I can store. I like that. That's a great concept.
And the other thing that's interesting is when I move that data around the world, you mentioned I've got hundreds of thousands of clients, and so we have multiple different data centers. There's obviously lots of different layers of privacy that come in. So we've got GDPR and CCPA.
Yeah.
There's all sorts of standards, and this is going to become a growing source of regulation. And so customers have to know the origins of the data. They have to know when they can ship data. And yes, we can do it in broad strokes. So we can say, well, my data center's in the UK. I know I can't ship data to the US out of this particular table. But we can also do it much finer grained. Imagine I've got a table which has all my customer data. I've got some US data, and I've got some UK data. I can send the US data to the UK, but I can't send the UK data to the US. I could set them up in separate tables, but in Aerospike, I've got that flexibility where I can say, look at the data before you send it, and based on the content of the data, work out whether we should ship it or not, or where we should ship it. So that I can say, have a field in there which says I originated from the UK, and therefore I can't ship out. I originated from the US, but then the UK could ship that record back to the US because it's originated.
So is that built into Aerospike already, like policy management, or what would you call that? It's your data management based off of a policy engine?
That's really our data shipping configuration.
Okay.
And that's all done absolutely transparent to the application. It's all configuration.
That's sweet.
So yeah, add a new data center, change your rules based on new regulations. All you have to do is change your configuration. You don't have to change anything in your application to be compliant.
That's where it should be. I think this is great.
Yep.
Right? Yeah, your applications really shouldn't know all the rules and regulations around data.
Yeah, it really reduces your time to market. One of the things there's a big push for is obviously security. As we're talking about systems of records, we need to make sure that your data is secure. So like an enterprise or all enterprise strength databases, Aerospike supports encryption at rest, encryption at flight, security, integration with things like HashiCorp Vault for secret management, things like that. So it really can be a system of record. And we have a number of customers in many areas, including financial services, who are using Aerospike as this system of record. And we're getting a lot of traction. There's a lot of goodness in Aerospike, and I've been with the company for over 5 years now and watched it grow. And the focus is on customer and success and making sure that we have the latest innovations in technology. As you know, when Intel came out with PMEM, we started using PMEM. And we use it in app direct mode because we want to make sure that we use it for its full capabilities. And this means that if I have petabytes of information, if I want to do a rolling upgrade of my cluster, the time it takes is very, very small. For a start, we'll be holding that petabyte in maybe 50, 60 nodes instead of thousands of nodes like our competitors. And when I can shut down a node, I don't need to rebuild anything. I can just shut it down, upgrade the software, and bring it back. And we're already attached to the same PMEM segment. And so you get this very, very fast restart times, and it becomes really easy to manage your cluster. And one of the things our customers say about Aerospike, which I really love hearing, is it just works. It sits in the corner and does what it says it's doing. And that doesn't matter if it's doing 5 or 10 million transactions per second over tens or hundreds of terabytes of data. It just works.
Oh, I love that. So if I were to summarize, we've got security, right? We have high availability. We have speed.
Yep.
And we have low latency. And scalability. I mean, you guys covered everything.
I would add strong consistency and very, very low cost of ownership.
And low TCO.
Very low TCO. So our customers who come to us tend to get faster performance, lower latency, higher throughput, more scalability, and they save a lot of money doing so.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.